Hello everyone. So now we'll discuss about the instruction set architectures. So first we'll see about CISC. So in CISC, it having the many different instruction, many different operand data types, many different operand addressing formats, relatively small number of general purpose registers, many instructions directly match high level language constructions. So in RISC, it having many fewer instructions than CISC. Example, the freeing chip space for more functional units. It's also having the fixed instruction format, example 32 bits, and simple operand addressing. And this is relatively large number of registers and small CPI and high clock rate. So architectural distinctions. So in CISC, it having the unified cache for instructions and data, multi-programmed control unit, and ROM in earlier processors. It may be a hardwired controls units now in some of the CISC systems. RISC, it having the separate instruction and data cache, hardwired control unit. Okay, so you can see the two different architectures. First one is CISC architecture with micro programmed control and the unified cache, and the second one is RISC architecture with hardwired control and the split instruction cache and data cache. So we'll see some of the characteristics of typical CISC and RISC architectures. So the first one, instruction set size and the instruction formats. In CISC, it is large set of instructions with variable formats, that is 16 to 64 bits per instruction. And in RISC, it having the small set of instructions with fixed 32-bit format and most register-based instructions. Second characteristics, that is addressing modes. So in CISC, it having the 12 to 24 addressing modes, and in RISC, it having the limited to 3 to 5. And third characteristics is general purpose registers and cache design. In CISC, it is 8 to 24 GPR, originally with the unified cache for the instructions and a data. Recent design also use split caches. But in RISC, large number, that is of 32 to 192 of GPR, with mostly split data cache and the instruction cache. So the fourth characteristics is CPI. So in CISC, CPI between 2 to 15, and in RISC, the one cycle for almost all instructions, and an average CPI is less than 1.5. So the fifth characteristics is CPU control. In CISC, earlier micro-coded using control memory, that is ROM, but modern CISC also uses the hardwired control. But in RISC, it having the hardwired without control memory. So this is all about the some of the characteristics of CISC and RISC architecture, that is a complex instruction set computer and reduced instruction set computer. So first we'll see that CISC advantages. So here in CISC, the smaller program size, it having the simpler control unit design, and it also contains simpler compiler design. So the advantage of RISC is it has the potential to be faster. It's also having the many more registers. So there are some of the problems in RISC, that is it is more complicated register decoding system, and the hardware control is less flexible than the micro code. So this is all about some of the advantages and problems of CISC and RISC.